So in this lecture, we will start today our first unit of B.Sc. Second Year Physics. Paper first, that is photoelectric effect. This module number 1, photoelectric effect, that is presented by me. So what is photoelectric effect? When a light of or electromagnetic radiation incident on a metal surface, then this light has some power, or we can say that light has two nature, that is wave and particle nature. If you consider particle nature, then light consists of photon. Then when it emits on a metal surface, then it ejects electron from that particular metal surface. This process of emission of electrons from a metal surface, when a light of suitable wavelength incident on it, is called as photoelectric effect. This can be explained easily by suppose आपण सोप्या भाषेमध्ये समजून घेऊ फोटोइलेक्ट्रिक इफेक्ट काय असतो. सपोज करा एक मेटल आहे, या मेटलवर आपण काय केलं, लाईट इन्सिडेंट केली. लाईट आपण जर इन्सिडेंट केली तर वी नो दॅट दिस मेटल कन्सिस्ट ऑफ लार्ज नंबर ऑफ इलेक्ट्रॉन्स. मेटलमध्ये फ्री इलेक्ट्रॉन्स ची संख्या खूप प्रमाणामध्ये असते. मग जर आपण एक इन्सिडेंट लाईट केली या मेटल सरफेसवर, देन ह्या मेटल सरफेसमध्ये जे काही असणारे इलेक्ट्रॉन्स आहेत ते काय करतील, बाहेर पडतील. ह्या प्रोसेसलाच काय म्हणतो आपण, फोटोइलेक्ट्रिक इफेक्ट म्हणतो. This phenomenon is called as photoelectric effect. That means phenomena of ejection of electron from metal surface when a light of suitable wavelength is incident on it. This phenomenon is called as photoelectric effect. हेच आपण या डेफिनेशन मध्ये आपण पाहिलं. तर जे इलेक्ट्रॉन त्या मेटल सरफेसच्या बाहेर पडतील त्यालाच आपण काय म्हणतो, फोटो इलेक्ट्रॉन्स म्हणतो. मग जर हे अल्कली मेटल्स असतील तर ते जे काही इमिट होणारे फोटो इलेक्ट्रॉन्स आहेत ते व्हिजिबल लाईटला सुद्धा इमिट होऊ शकतात. दॅट मीन्स वी कॅन से दॅट द इलेक्ट्रॉन्स फॉर अल्कली मेटल्स फोटो इलेक्ट्रिक इमिशन ऑकर्स इवन ॲट अंडर ॲक्शन ऑफ व्हिजिबल लाईट. Zinc, cadmium are sensitive to visible light. That means there is a easy ejection of photoelectrons from this zinc, cadmium. Graphical diagram of photoelectric effect. The apparatus consists of two plates, that is A and C. That is one is acts as anode and another is acts as cathode. The galvanometer G and battery are connected, which is shown in this above figure. When ultraviolet light is incident on negative plate C, that is we know that cathode has a negative charge, hence incident on negative plate C, then current flows in the circuit which is indicated by G. That means there is a conduction of current due to these electrons. But when light falls on positive plate A, there is no current in the circuit, and this incident same light, if incident on that particular anode, then there is no phenomena of electron or flow of electron. That means there is no current in the circuit. That means for the conduction of current, we have to incident this light only on cathode. This observation shows that photoelectric particle must be negatively charged, that is electrons. That means on incident on this cathode, the phenomenon of flowing of current takes place. That means these charged particles are nothing but electrons. To explain this phenomenon of photoelectric effect, we have two methods. That is, first one is Lennard's method to determine E by M of photoelectrons. That is, E by M means charge on electron divided by mass of electron. That is, this is a ratio, that is charge upon mass of photoelectrons. For that, this is a diagrammatic representation of Lennard's method. The apparatus used is as shown in above figure. It consists of a glass tube G, which can be evacuated through a side tube T. That means this is a side tube and this is a glass tube G. When ultraviolet light passes through this quartz window W and an incident on an aluminum cathode C, which is enclosed in G. That means in G there is a cathode and anode. We can see here ultraviolet light passes through quartz window W. That means we have to incident UV light from this window, and cathode is presented at this particular point. The cathode is made up of C. And earthed metal screen A with a small central hole forms an anode. That means anode is present at this point, that is A. Cathode is here and anode is here. The cathode C can be maintained at a desired potential, positive or negative, related to anode A. That means we can keep our cathode or anode positive, negative with respect to anode A. P1 and P2 are small metal electrodes connected to electrometers E and E1 and E2. That means these P1 and P2 are small metal electrodes which are connected to this E1, this is E1 and this is E2. Then this is the explanation of that particular Lennard's method. When cathode C is applied to negative potential and illuminated, negatively charged particles, which are nothing but electrons, are produced and accelerated towards anode. We have seen a definition of photoelectric effect. म्हणजे एखाद्या मेटल सरफेसवर जेव्हा लाईट पडते तेव्हा त्या लाईटचे जे काही फोटॉन असतात ते काय करतात, त्या इलेक्ट्रॉन्सला एनर्जी इम्पार्ट करतात. त्यामुळे ते इलेक्ट्रॉन त्या मेटल सरफेसमधून बाहेर पडतात. त्या फिनॉमिनालाच आपण फोटोइलेक्ट्रिक इफेक्ट म्हणतो. मग हाच जेव्हा cathode C is applied to negative potential and illuminated, that particular electrons or negatively charged particles are produced and accelerated towards anode. We know that anode have positive charge and cathode have negative charge. A few particles pass through hole A and proceed with uniform velocity P1. Their arrival at P1 is indicated by E1. We can see in this diagram this P1 electrons when arrive here. We can see with this electrometer E1. By applying uniform magnetic field, it is represented by a dotted line perpendicular to the plane of the paper and directed towards the reader. The photoelectrons can be deflected towards P2. Their arrival at P2 is indicated by a deflection produced in E2. That means the arrival of photoelectrons at P1 is indicated by E1, and this is perpendicular magnetic field applied here. That means this B is perpendicular to plane of paper, and due to this magnetic field, the electron deflected in this side, and their arrival at this point can be indicated by using this E2, electrometer E2. Then Lennard first studied the relation between current and potential at C. That means Lennard studied the behavior, that is relationship between current and potential. And the cathode potential was several volts positive, the current was 0. That means we can see here This is a negative values of potential, that is -5, -10, and these are the potential positive value. When the potential is positive, then this particular current is, we can say, potential is 0, and when the V was +2 volt, there was a small current showing a few particles possessed through the enough velocity to overcome the retarded potential 2 volt. That means this is a +2 value we can see here, and if we apply negative potential, then this value is increases negatively, and at a particular point this value gets constant, and the potential was further decreased. That means here negative values are increased. That means we can say that when the potential was further decreased, the current increased and reaches the value of -20. We can see here shows the variation of photoelectric current with cathode potential. Then we can solve the mathematically. After the preliminary investigation, Lennard applied to cathode a negative potential V, very large compared to the potential of +2 volt. The velocity imparted by the accelerating potential is so large that velocity of particle in the act of emission is negligible in comparison to it. Suppose we have consider capital V is the accelerating potential and small v is the velocity acquired by electrons. Then the kinetic energy is equal to this potential due to this electric charge, that is charge on electron, that is half mv square equals to E into V, where E is the charge and m is the mass of photoelectrons. And if we consider capital R be the radius of circular path due to this magnetic field, then this centripetal force, that is circular magnetic field, is equals to that magnetic force, that is BeV. Then small v we can get cancelled here. mv upon r equals to BE. From that we can calculate the value of V here. That particular value of V we can put this value in equation 1, that is half m BER whole square upon m equals to EV. Then by squaring and solving, we can get the value of E by m, that is E by m, that is charge upon mass of electron equals to 2V divided by B square R square. Then by knowing the value of V, B and R, we can calculate this ratio, that is E by m. Lennard found that the value of E by m to be same as that of electrons. This clearly shows that the particles are nothing but electrons. Hence, by knowing the value of these, we can easily calculate, and our answer is similar to the ratio when the particles are electrons. Thank you.